Well, hello everyone, and we're off to the first topic, the basic math review. And part of the reason we do this, and it's going to start very basic, is because I know for a lot of you, you have not had math in some time. Some of you might be sophomores, juniors, or seniors, might not have had any math from or since freshman year or even since high school. For those of you who are returning students, you might not have even had a math class in 10 or 15 or even 30 years for some people. So we'll just go through relatively briefly and hit some of the basics. So what are we going to talk about? Well, first we are going to talk about what you need to know, what is a must from this. Then we're going to talk about what would be useful, and then go over practice and review problems. And during this time, I will encourage you to pause the recording, to work through a series of problems on the screen, and then restart or resume, excuse me, the recording, and you can see how you did. So first, just to give you a little taste for how off we can be with our mathematical failings at times. One of the most vivid arithmetic failings displayed by Americans occurred in the early 1980s when the A&W restaurant chain released a new hamburger to rival the McDonald's Quarter Pounder. With a third pound of beef, the A&W burger had more meat than the Quarter Pounder. In taste tests, customers preferred A&W's burger, and it was less expensive. A lavish A&W television and radio marketing campaign cited these benefits. Yet instead of leaping at the great value, customers snubbed it. Only when the company held customer focus groups did it become clear why. The third pounder presented the American public with a test in fractions, and we failed. Misunderstanding the value of 1/3, customers believed they were being overcharged. Why, they asked the researchers, should they pay the same amount for a third of a pound of meat as they did for a quarter of a pound of meat at McDonald's? The 4 in 1/4 larger than the 3 in 1/3 led them astray. Don't be these people. All right. So, what do you need to be able to do here? Well, you need to do all of the math in this PowerPoint, and you will also need to do it in the way that we talk about it, but we'll get to that in a second. If you do not get to a point where you will be able to accomplish this math in this PowerPoint, you are not, I promise, not going to be successful in the class. And in many ways, taking a math class or a statistics class is a lot like learning a foreign language. It is very, very different in the notation. Some of the symbols you are going to see would be like letters you've never seen before. So you need to know the basics in order to build up. As I have on the screen, this would be like trying to write a book without knowing the alphabet if you are trying to do a math problem without knowing the basics of it. So we need to get this down, and hopefully due to the nature of this course and how I've structured it, you'll be able to do that, be able to return to even this lecture over and over again if need be. Second point, the only math that we will discuss and the only ways we will discuss to do it will be how we do it for problems in the class. Meaning, yes, we're going to talk about fractions on this, but you don't need to simplify fractions. In class, you're going to be able to use a calculator. So if we don't go over it a certain way in this lecture, you don't need to know it. All right, so let's move on now to what would be useful for you. Now, even if you think you know all of the math, you should run through this again, because I promise you're going to mess up something, or at least you probably would have if I didn't tell you that. In general, students lose more points on assignments and exams by making minor mistakes. For example, not adding things in their calculator correctly. If you take 5 plus 4 plus 5 plus 5 and you accidentally hit 5 instead of a 4, then you're going to be wrong, not because you can't do the math, but because you've messed up on the calculator. Or you might put the notation in the wrong way, write down the problem incorrectly. There are many, many ways you can mess up these problems, so please work through these just to be sure you've got it down. And also, as I previously mentioned, use this as a guide. So when we get to standard deviation, you're going to have to do summation. So if you don't understand summation when we get to standard deviation, then you can come back and look at this, use it again. Or, of course, you can ask me in class, but this is just, perhaps you're having issues at night working on a homework assignment due the next day or trying to cram for a test. Come back and use this. This should be your friend. All right, well, let's move on to negative and positive numbers. And as I said, this is really, we're starting basic. So you should feel good about yourself if you are already getting more confident. So when we are going over these things, I'm just going to give you kind of the rules that are set out. So for example, a positive number plus a negative number is really equivalent to subtraction. So 5 plus negative 3 is equal to negative 2. So the negative sign with the negative 3 really kind of almost cancels out the positive sign, if you will. So anytime you have a positive number and you add a negative number, it's really like you're subtracting that number. Similarly, if you have a negative number and you add a negative number, it's still subtraction. So negative 5 plus negative 3 is just the same as negative 5 minus 3, which would be negative 8. So that adding a negative, subtraction. Now, if you take any number and you subtract a negative number, the negative signs kind of cancel each other out, and we're back to addition. So 6 minus negative 4 is really equivalent to 6 plus 4. So that would be 10. Or negative 3 minus negative 1 would be negative 3 plus 1 would be negative 2. So you have a number and you subtract a negative. It's really like adding that number. If you have a positive number and you multiply it times a negative number, your outcome will always be negative. So the negative sign is going to be staying. So 4 times negative 6 is equal to negative 24. Any positive number times any negative number will give you a negative number in the end. Alternatively, if you have a negative number times a negative number, you end up with a positive number. Remember that these things cancel one another out. So negative 2 times negative 9 is equal to 18. So negative times a negative equals a positive. Now when it comes to dividing, it's very similar. If you have a positive number divided by a negative number, you get a negative number. And truthfully, if it's a negative number divided by a positive number, it's also negative. So 10 divided by negative 2 is equal to negative 5. A positive divided by a negative is equal to a negative. Now, if it were negative 10 divided by 2, so a negative divided by a positive, you would also have negative 5. And a negative number divided by a negative number, you're going to end up with a positive number. Once again, these negatives kind of cancel out. So negative 8 divided by negative 4 is equal to 2. All right, as a brief reminder, in the example problems coming up for negative and positive numbers, you're going to see a couple cases where the numbers are next to, well, one number at least is next to a parenthesis with no operation, no addition, subtraction, multiplication, division, etc. So in the first case, 2 in parentheses times in parentheses 4, what that means when you see these two numbers next to each other, that means that you multiply them together. So 2 times 4 is just equal to 8. And it might, right now you might look at it and say it looks weird, you can't quite tell that means multiplication. This is something you're just going to have to memorize. So if you see negative 3 in parentheses next to 10, that's just 3 times a negative 3 times 10 equals negative 30. You see 5 and parentheses 8 next to it, that's 5 times 8 equals 40. Negative 9 times negative 1 is equal to 9. This is just something that you're going to have to get used to over time. Okay, so now this is the first case where I'm going to give you some sample problems up on the screen. You go ahead and work through them on your own, and then pause the recording. And then when you are ready to see what the answers are, just unpause it, resume the recording, and we'll go from there and go on to the next topic. So go ahead and pause. Okay, so if you have resumed the recording, I assume you've made it through. So let's go through all of these. So negative 5 plus 4, well, that's fairly straightforward. Negative 5 plus 4 is just equal to negative 1. Second one, 6 minus negative 2. Remember we said that if you take a number and subtract a negative, it's really like adding. So 6 minus negative 2 is equivalent to 6 plus 2, so it's equal to 8. For number 3, negative 6 minus 4 plus 2, well, negative 6 minus 4 is negative 10, plus 2, negative 8. Fairly straightforward. For the fourth one, 3 times negative 4, remember, in this case, it's a number next to a number in parentheses, so it's multiplication. So 3 times negative 4 is equal to negative 12. For the fifth one, 3 times 4, straightforward, 3 times 4. 6, negative 3 times negative 4, a negative times a negative is a positive. So negative 3 times negative 4 is 12. For number 7, negative 3 plus 4, now, because there is an operation, it's not multiplication between these two numbers. It's just negative 3 plus 4 equals 1. Number 8, negative 4 times 1 times 2 times negative 3. Well, let's work through this in turn. So negative 4 times 1 is just negative 4. So negative 4 times 2 now, a negative times a positive is still a negative. So negative 4 times 2 is negative 8. And negative 8 times negative 3, well, a negative times a negative is a positive. So negative 8 times negative 3 is equal to 24. Number 9, negative a times negative b times c times d. We're going to get into, if this one is messing you up just because it has variables in it, we'll get into that later. But negative a times negative b would just be a negative times a negative is a positive, so just a times b. So ab. If you take a times b times c, that's just a, b, c. But now, because you're multiplying a, b, c times negative d, you flip it back to a negative. So let's work through it again more quickly. Negative a times negative b is a times b. A times b times c is equal to a times b times c. And a times b times c times negative d makes it negative a, b, c, d. All right, number 10. Negative 4 divided by negative 3. Well, you could simplify the fractions if you really wanted to. But for the purposes of this class, I'm completely okay with you using a calculator. So you could simplify it to 1 1/3 or just 4/3 by getting rid of the negatives. Or you could just take negative 4 divided by negative 3, where you would get 1.33. All of those are right. In this class, I would suggest you just use your calculator in all fractions. Okay, now let's move on to 11. It's 10 times 3. Remember, there's no operation, so that means multiplication. 10 times 3 is 30. 30 divided by negative 2. We know we're going to get a negative number because it's a positive 30 divided by a negative 2. So 30 divided by 2 is 15. We know it's negative, so negative 15. And then finally the last one, number 12. This one's just annoying, but that's life. So negative 1 times negative 1, negative times a negative is positive. So negative 1 times negative 1 is 1. 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. And positive 1 divided by negative 1 is equal to negative 1. All right, if any of these don't make sense to you, we'll work through them more slowly in class if you have a question. But this is an example, or could be for you, an example of where you're listening to the recording and there could be a problem. You should circle this if you don't get something and bring it to class and ask me about it. That's what class is going to be for in the way that our class is structured, is so you can come and ask me questions that you need to know. I don't want to go through all of these for you if you don't need them. If you've already got them, good. But if there are some that are issues, please bring them to class and we can go over them. All right, let's talk about fractions. So, as you probably already know, fractions are annoying for students, and students don't like fractions, and I understand. But for us, we have calculators in this class, and I'm completely fine with it. So all you really need to know is that in fraction, when you have fractions, it's equivalent to division. So 3/4 is equal to 3 divided by 4, which is 0.75. Or the same notation is just 3 over 4. That means the same thing. So if you see a 3 over 4 or 3 divided by 4, just do the division. That's fine with me. As I said, we will not need to do common denominators, anything like that. This is an example of what I said on, I think it was the second slide, where I said you only need to know how to do the math in this class, as we're going to do it in this class. Don't need to do anything but this. Therefore, what is 2 divided by 5 plus 3 divided by 8? Well, if you could go through and get a common denominator if you really wanted to. But for us, why don't we just take 2 divided by 5 and say that's 0.4 plus 3 divided by 8. 3 divided by 8 is 0.375. So we get 0.4 plus 0.375 equals 0.775. For us, that's as complex as it needs to be. If you have questions about how to work this or want more problems after we go through this next set, then please bring them to class. All right, so at this point in time, I'm going to ask you to pause the recording and finish all of these problems. Then you can resume the recording when you're ready, and we'll go through the answers. All right, well, if you're back with us, I assume you are good to go, so let's take a look. So, first one, fairly straightforward. 6 over 3, 6 divided by 3 is equal to 2. Number 2, -4 divided by -3. You're going to see there are several different ways you could write this out. You could just have the negatives cancel out and have it be 4/3. You could simplify to where it's 1 1/3. But really for us, you would be just fine taking -4 divided by -3 and getting 1.33 on your calculator. And you can see for multiple ones of these, you can, I have them multiple ways for you. Number 3, remember if a number is in parentheses next to another number with no operation, that means multiplication. So number 3 is 3/4 times -1. So that's just -3/4 or -0.75. It's the same thing. For number 4, multiple ways you could do it. It could be 0.5 times 0.33 or 1 divided by 2 times 1 divided by 3. Does not matter to me. You're going to end up with the same answer in the end. In number 5, again, if you wanted to, depending on how the equation works itself out, you could simplify 1/2 to 0.5 and 6 divided by 3 to 2. So it could be 5 times 0.5 times 2 times 2. Or you could just work it through as is. It doesn't really matter. You're going to hear me say that a lot. Regardless, the answer is 10. For number 6, 7 divided by 8 divided by 1 divided by 2. Once again, work itself all the way through. And I'm just going to cut it there because you can see for number 6, 7, and 8, it's the same type of situation. For number 9, 5 minus 8 divided by 2, it's really just 5 minus 4, so 1. And then number 10, this is where you're going to be really appreciative that you have a calculator. You could go through and figure out that 60 is the common denominator by taking the denominator of all of the numbers and multiplying them together. Or you could just use your calculator and come up with around 7.216, depending on how you are rounding. All right, next up, let's talk decimals and percentages. First thing, we got to talk about rounding. So in this case, in this class, we are always going to round to 2 decimal places. Why? Really because I want it that way, and I can tell if your work is similar to someone else's. So honestly, it's just because I want it that way. We're not worrying about significant digits or anything like that. 2 decimals. All right, so how do we do it? Well, when you are rounding to 2 decimals, and this is true for all of them and kind of the mechanics of how you do it, but we're going to stick with 2, you look at the third decimal place. So if it is 3.514, you would look at the third decimal place, or the 4 that is underlined. And if that third decimal place is less than or equal to 4, you leave the first 2 decimals the way they are. So it would be, because 4 is equal to 4, you leave the first 2 numbers, the first 2 decimals. So 3.514 rounded 2 decimal places is 3.51. Fairly straightforward. Now, if the third decimal place is greater than or equal to 5, you move the second decimal place up 1. So 4.438, you look at the third decimal place, it's 8. 8 is greater than 5, so you round up the second decimal place. So 4.438 is now 4.44. Rounding is something most people are pretty good at. If not, please feel free to bring questions to class. But regardless, everything needs to be 2 decimals. You're going to lose points if it isn't. Even if you are more accurate because of significant digits, I don't care. 2 decimal places. Okay, now let's talk about percentages. Now, percentages are really just decimals when you think about it. So to convert from a decimal to a percentage, you just move the decimals 2 places to the right. So the decimal being 0.75 in this case, well, you move the decimal place 2 places to the right. So you move it from before the 7 to past the 5. So it'd be 75%. 0.75 is equal to 75%. You move the decimal 2 places to the right. In this case, 3.49, you move the decimal 2 places to the right. So it'd be 349%. Now, if you need to get from a fraction to a percentage, the first thing you'll do is convert the fraction into a decimal, and then move the decimal over. So 2 divided by 5 is equal to 0.4, and that is equal to 40%. Because if you take 0.40, move the decimal place over twice, you get 40%. So 2/5 is equivalent to 40%. Now, if you want to convert from a percentage to a decimal, well, now you move the decimal 2 places to the left. It's just the opposite of what we had done. So 83%, you move the decimal over 2 places to the left, is equal to 0.83. That's the decimal. Or if it's 0.04%, you move the decimal place over 2 more times, so 0.0004 in this case. Now this one is a little bit different, just in the wording though, you can already do this. So if someone says take x% of y, really what it means is you multiply y by x%. So if someone says take 10% of 100, it means multiply 100 by 10%. And we know that 10% is equal to 0.1. So in this case, if you want to take 10% of 100, it would be 100 times 0.1. So let's walk through that again. So if it's take 10% of 100, the first thing you do is you take your percentage and convert it to a decimal. So 10% is equal to 0.1. Then you multiply whatever the number is, in this case 100, times that decimal. So 10% of 100 is 10. If someone says take 27% of 147, well, it's just 147 times 27%, which is equal to 147 times 0.27, which is equal to 39.69. So 39.69 is equal to 27% of 147. Okay, so now let's just work through some of these problems. As before, I'm going to pause it, then we'll walk back over them. All right, let's get to the answers. So if you're going to round off at 2 decimal places, In this first example, 3.5741, well, you look at the third decimal place. In this case, it's the 4. The 4 is equal to 4, less than 5, so you're going to keep the decimal places prior to it the same. So 0.35741 rounded to 2 decimal places is 0.357. Similarly, you look at the third decimal place in 10.111, etc. It's a 1. Well, 1 is lower than 5, so you keep the decimal places the same, so it's just 10.11. The third example, 90.0054, we look at the third decimal place, the 5. It is equal to 5, greater than or equal to 5, so you will move up the prior decimal place. So it'll go from 90.0054 to 90.01. In the fourth example, 9.0009, well, we still look at the third. This might be kind of an illusion to some people, but you look at the third decimal place, it's 0. 0 is less than 5. So you keep the first two the way they are, regardless of there being a 9 at the end. And the final decimal, 43.52500. Look at the third decimal place. It's a 5. That means you round up, so it would be 43.53. Now, let's look at some percentages. 0.75. Well, to get from your decimal to your percentage, you move the decimal place 2 places to the right. So instead of 0.75, it is 75.0, so 75%. The same with the second example. You take 0.7532, move the decimal place 2 places to the right, so you have 75.32%. The third example, 1.5, again, move the decimal place over twice, 150%. Now for the fourth one, well, what do you do? To get first from fractions to a decimal, you just divide. So 2 divided by 3 is equal to 0.666. If you are to make that into a percentage, you just move the decimal place over twice. So from 0.6666, you have 66.66. And then finally, 1 minus 0.77. What is that as a percentage? Well, 1 minus 0.77 equals 0.23. So to get from a decimal, 0.23 to a percentage, just move the decimal over twice. So 23%. And now for the bottom 3. This gets to the last bullet that we talked about on the prior slide. To get 20% of 100, well, 20% is just equal to 0.2. So the first one really is 100 times 0.2 equal to 20. Second one, hey, that is 0.2 times 100 equals 20. And the last one, 0.20, well, 0.0 times 100, remember, numbers in parentheses, equals to 20. So all of those last ones are the same way of saying the same, well, different way, excuse me, of saying the same thing. All right, let's talk now about exponents and roots. We have a lot of exponents and roots in this class. I promise you that. What you need to do, 2 things. The first one is get practice with your calculators. Some people are going to bring new calculators to tests and inevitably will have problems because they don't know how to use their calculators. Some calculators have their buttons set up in different ways. So what I need you to do is get a calculator, a cheap calculator is fine, and bring it to class every day and have the one you bring to class be the one you use on exams. While in class, I will be fine if you want to use your phone as a calculator. You cannot use your phone as a calculator on the exam. So I really, really hope that you'll take my advice, get yourself a calculator, bring it to class, and bring that same calculator to your exams. That way you can work through, you know exactly how the calculator works, and you don't have to have a mini meltdown in the exam where you don't know how the buttons work. Now the next one is just get practice with your calculations when you're doing them by hand. And why is this? Well, let's take this example I just put up. 127 times 13 plus 11 times 0.27 times 1 divided by 22 plus 1 divided by 28, and the square root of all of that. Well, some people, when they put the square root, it'll look like this, where you can't quite tell where the square root ends. You, I promise you, will mess up, specifically in the t-test, but we'll get to that later, when there are some additional calculations you have to do under a radical, but you don't, and a radical is just the sign for that, the square root symbol. And you don't know where the radical ends. Or you'll put it like the one I have on the screen and kind of assume that it's the first part and that the second part of the parentheses aren't in there. So I will want you to practice making sure your line goes all the way across. And it sounds ridiculous, but I promise you it will help. And even more, I don't even do that. When I'm doing problems, I do what I have up on the board. I draw a little line at the end. So I almost am including everything in there under the radical. And you don't have to do it that way. You can put smiley face at the end for all I care. Anything that will tell you what needs to be under the radical is good enough for me, as long as you are able to do it. This is the equation I was telling you about before, the t-test equation. You don't need to worry about doing it now. I promise I can get every one of you through being able to do this, and it will all make sense. I promise. But you can see, if you look where I have my mouse now up on the screen, this radical, if you ended it here, you might think you just square root this chunk and then multiply this chunk afterwards. Or, and this isn't what we were talking about previously, but similar concept, if you miss some of the brackets, do you just square root what's on the top, or do you do what's on the bottom also? So that's why it's so important, and why teachers will tell you over and over again that you need to show your work, in part because when you start in these complex equations, just assuming you know how to do something, you're probably going to screw it up at some point in time. So please, please be careful. Okay, so there's not a whole lot for me to explain on these slides, other than you'll have to excuse that right here, the radicals, the way that my Microsoft Office has it set up, you can't very easily put everything under a radical. So just trust me. In this case, this is 4 squared, the square root of that. This is just the square root of 22,547, etc. So there's just a square root of everything there. But go through with your calculator, make sure you can do all of these, pause the recording, and then we'll pick it up. Okay, so hopefully you were able to get through your calculator on all of that. So first one, 5 squared equal to 25. Hopefully you could find that button on your calculator. 32 squared, 1024. 3 squared is equal to 9. Number 4, well, if you take 4 and you square it, it's equal to 16. And then you take the square root of 16 is equal to 4. Or you could get to the point where you know that the square root and the squaring cancels each other out, so you could just leave it at 4. Then the last 4 problems are just ones that you should be able to do on the calculator fairly easily. You just got to find the square root button. But some people will have to put in, for example, on number 5, some people's calculators, you'll have to put in 22,547 and then hit square root to get your answer. But for some people, you have to put square root and then put in the 22,547. So this is where it's important that you know what your calculator requires of you. If you're having calculator issues, please bring it to me in class and we can talk about it there. Okie dokie. Now we're moving on to order of computation, or order of operations, depending on how you want to say it. This is possibly the single most important thing for you to get right now, because, as we've seen previously, there's going to be a lot of calculations going on. So the thing for you to remember is PEMDAS, or please excuse my dear Aunt Sally. What this means is that you do in order parentheses, exponents, multiplication, division, addition, and subtraction. It's a little mnemonic device you might have remembered from, I don't know, 8th grade or 7th grade or whatever it was before. So please remember this. Well, please remember PEMDAS. And If you are so inclined, I would even suggest writing at the top of pages of exams or assignments or work that you are doing just to remind yourself. This will set you free. If you are having problems with any kind of formula, this is where you need to turn. As I said previously, when you see an equation, you do it in order of PEMDAS. So in the case of 5 minus 2 times 3, what do? Well, we have subtraction and we have multiplication. So let's look. Well, we don't have parentheses, we don't have exponents, we have multiplication. So in order of operations, what you would first have to do is 2 times 3. Then take 5 minus that. So it really is 5 minus 2 times 3 is equal to 5 minus 6, which is equal to negative 1. It is not 5 minus 2 equals 3 times 3 equals 9. That is incorrect. If you did that, you are not paying attention to order of operations. So you need to make sure every time you're looking through something, you know what you are looking for. Now, if you did see 5 minus 2 times 3, you would do the parentheses first because PEMDAS, first one, parentheses. So you would do 5 minus 2 first. So it would be 3 times 3 in that case. But it's only because there were parentheses. Don't have parentheses, don't do parentheses. So I am in all cases going to give you formulas. I don't think that in the real world you don't really need to memorize formulas. At least anybody in this class probably won't need to. Some people do, but those are statisticians. That's not where we're pointing towards in this class. We just want you to be able to do them. So you will have access to all your formulas. And what that means is you don't need to spend time memorizing them. You need to spend time working on them, and you'll need to remember PEMDAS. You'll be able to complete all of your formulas that way. And this is one that I expect you to bring questions to in class. If you don't, I'm going to wonder about you. Almost everyone has issues with at least one of the problems. And again, for order of computation, let's look at that formula we looked at before for the t-test. Well, yeah, where do you start with this? Right now, you probably would be scared to death if I asked you to do it, which I'm not. But this is why it's so important that if you look, you say, well, we do have an exponent, so what's under, we do have a radical, we have a square root. So what do you then do? Well, you got to look to the parentheses. Well, inside these brackets are additional parentheses, so you would know you'd end up having to do n minus 1 first and n minus 2 minus 1 first, then multiply those two together, then add them together, then divide it by this whole chunk here. So you can see how it can get complicated over time. If you don't know order of operations, you have no chance to be able to do this. So please bring questions to class. All right, so it's time for practice. I'd go ahead and write down PEMDAS on the paper you're going to be doing these on, and I'll pause it, and then we will work through the problems briefly. Okay, hopefully now you are good to go, so let's check it out. So 3 plus 2 times 4 divided by 5. What is the order of operations you do here? Well, multiplication and division are before addition. So you know you have to do 2 times 4 first. So it's really 3 plus 8 divided by 5. If you then do the next part, that would be 8 divided by 5 as the next step, and 8 divided by 5 is 1.6. So 3 plus 1.6 is equal to 4.6. So in this case, no parentheses, no exponents. You just have multiplication and divisions. You do them first. Next, well, in this case, number 2, we do have parentheses. So you know the first thing you have to do is 4 divided by 5. So 4 divided by 5 is equal to 0.8. Next, we have multiplication. So 0.8 times 2 is equal to 1.6. And 1.6 plus 3 is equal to 4.6. Sound good? Hopefully it does. Number 3, we do have parentheses, so you have to do 3 divided by 2 first. So 3 divided by 2 is 1.5. Next up, 1.5 times 4 is equal to 6. And now 6 divided by 5 is equal to 1.2. For number 4, we have parentheses again. So inside the parentheses, which one do we do first? Well, we know we do multiplication before addition. So in this case, it's 2 times 4 is equal to 8, plus 3, so that's 11, and 11 divided by 5 is equal to 2.2. Then finally, the difficult one. And this is one that if you didn't get it, we probably have to work it out by hand in class. I can do it on the board and we can go step by step. But nonetheless, we have 2 parentheses in this case. So we know we'll have to do this chunk first and then this chunk. So in here, we have another division. We have an addition and a division. We know we'll have to do these 2 divisions first. So 1 divided by 2 is 0.5. 7 divided by 4 is 1.75. So 1.75 plus 0.5 is equal to 2.25. 2.25 divided by, well, now we got to get the next chunk. So 2.25 divided by, in parentheses, well, we see first we have addition and we have division. So we first have to do the division. 1 divided by 2 is 0.5. 2 plus 0.5 is 2.5. So we end up with 2.25 divided by 2.5. And 2.25 divided by 2.5 is equal to 0.9. Again, I know this is either the hardest or second hardest part. It's probably, for many of you, not even hard. It's probably just confusing. So the best way to get through the confusion is simply work through it a bunch of times, and we'll get plenty of practice. All right, last one we have is summation. Now, as I say on here, of all of the math we have today, this is the one I will expect you to recognize the least. And it's also one of the most important. It kind of is the underlying aspect of most, if not all, statistics. Summation is denoted by the Greek capital sigma, as you see on the on the screen, this E-looking thing. And all that sigma means is add up whatever follows it. So in this bullet point here, sigma x means add up all of your x values. Critical to know here is summation is only used when we have data from more than one person. Think about it. Why would you add up all of the x's if there weren't more than one x, right? There would be no point. So sigma means add up all of whatever is coming after it. So let's say we have these scores on happiness from 5 different people. And let's say happiness, we are calling it variable h. So if we did the sum of h, it would be 3 plus 2 plus 5 plus 4 plus 5. So the sum of h is equal to all of the h values you have. If you had more happiness values, you would do all of them. If you had 10 of them, you'd add up all 10 of them. It does not matter. It's whatever the values are that you have. Now, one of the things that people ask is why we have this. Why on earth do we do this? This seems more complicated. Well, when we have a data set, we want to be able to identify our values. So let's say that we have this table here. We have some variable x. Well, we want to be able to identify this is x1, the first x value, the second x value, third x value, all the way down. When we are wanting to add up all of our x scores, we could simply make an equation in this case for x1 plus x2 plus x3 plus x4 plus x5. And that wouldn't be too terrible. But remember, when we are dealing with data, we can have hundreds, thousands, or millions of data points. So instead of x1 plus x2 all the way up to x5, A similar equation would have to be x1 plus x2 all the way up to x 1 million, or however many values you have. That would be really annoying. So we get around this by just putting the sum of x, which just means, or the sum of whatever it is. So the sum of x just means add up however many x values you have. So summation, this is one that I'm gonna give you a shot. If you are confused off the bat, that's fine. We'll work through it. And again, I would expect that we'll go over this in class. So if you think you can do this, go ahead and try to work it out. And just as a hint, this is the sum of x, so it would be all of those x values plus the sum of y, all of those y values. So pause, and then we'll start up again. All right, so if you think you're good, let's check it out. So in this case, the sum of x plus the sum of y. Well, really, summation is adding up each of the x values individually. So 1 plus 2 plus 3 plus 4 plus 5, that equals 15. Plus, no surprise, the opposite order of those is also 15. So it's 15 plus 15, you get 30. Second one is a little bit more difficult. And what you would do here is first look and see what is my order of operations. What does it say to do? Well, in order of operations, you square things before you add them. And remember when I said in the last slide that summation is really the same as saying x1 plus x2 plus x3 plus x4 plus x5. Well, so summation really in order of operations is just addition. So in this case, what you would end up doing is you would square 1 and square 2, square 3, square 4, square 5. And then you would add them all up. So you would do the squaring first. And that's the same for the y values also. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. If you add 25 plus 16 plus 9 plus 4 plus 1, you end up with 55. And just like with the first problem, this is just the opposite of that. So 25 plus 16 plus 9 plus 4 plus 1. Be 55 plus 55, which equals 110. Next up, this again gets a little complicated. We have all of our x values, all of our y values. We first are going to do what's in parentheses, just x plus y. Well, in this case, we don't have one x value and one y value. We have the variable x and the variable y. Therefore, we add x plus y first. So 1 plus 5. So you add the first x plus the first y equals 6. Then you do the second x plus the second y. So x1 plus plus y1 is 6. 2 plus 4 is 6. 3 plus 3 is 6. 4 plus 2 is 6. 5 plus 1 is 6. 6 plus 6 plus 6 plus 6 plus 6 equals 30. That one is important to know, and we will go over it in class some more. Next up, we have a similar one as before, but now we got to square our values first. So this would be 1 squared, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared is 25, and the same over here. So in this case, it would be 1 squared, and then you add those together, excuse me. So this would be, in the first case, 1 squared is 1 plus 5 squared, which is equal to 25, that's 26. The second one, we square 2, you get 4. You square 4, you get 16. Then 16 plus 4 is equal to 20. We again square our x, so 3 squared is 9. 3 squared is 9. You add your x plus your y equals 18. Here we square our x. 4 squared is 16. 2 squared is 4. 16 plus 4 is 20. And as with this first row, the last one is equal to 26. Once you've done everything in the parentheses, then we add them all up. So if you add up all of those values, it equals 110. This is where it gets complicated, when you've got operations and operations all together. We will work through this in class, although I'm probably going to require one of you to ask me to go over it. Next up, the sum of x plus y squared. Got to go back to PEMDAS. Remember, parentheses and then exponents. So we know we first have to do parentheses. What's in the parentheses? It's x plus y. So 1 plus 5 is equal to 6. 2 plus 4 is 6. 3 plus 3 is 6. 6 is all the way down. Then, once we've done our parentheses, what's next? Well, remember, this is exponent. This is just addition. So we do the exponent first. So we would take our 6's and then square them. 6 squared, 36. 6 squared, 36. All of our 6's are 36. All of our 6's squared are 36. So when you get 36 5 times, add them all up, that equals 180. And then the final one. This one, we got a lot of parentheses, we got exponents, so let's get to it. So first thing we got to do is say, here's a parenthesis, here's the end of the parenthesis, we see our exponent is outside it. We know we've got to do what's in our parentheses. Inside the first parentheses is the sum of, in parentheses, x plus y, end parentheses. So we know we have to first add our x plus y. So 1 plus 5 is 6, as before we get all 6's. Now we know we have to sum them, because this is inside the parentheses. That is outside. So we do the summation first. So if we add 6 plus 6 plus 6 plus 6 plus 6, we get 30. When we get 30, then the last thing we do is we square it, and 30 squared is 900. Okay, so I'm hopeful that we have a better idea of what we're doing, and you have a better idea of what you need to work on now. I'm hoping that through all of this, it's, for some people, maybe it makes you feel good. For other people, maybe it scares you. For all of you, what it should do is it should give you a better idea of where you are in terms of your ability and what you need to do. Before the first test will have summation on it. So you need to be able to do this. This is probably, this or order of operations, be the first place to start. So come to class next time knowing what you need to do, what you have questions about, and where to go. The where to go part is really dependent upon you. If you feel like you need help on order of operations, I will have some practice problems in class and go over order of operations. If you feel like you're good with order of operations but you need summation, then you can come and work on that. If you feel like you are good with everything, that means we're moving on to the next. You can move on to the next module and you can get ready to start looking at some of our descriptive statistics that will use the information we have here. And this is why I'm doing the course this way, is I want you to work at your pace. I want you to come knowing what you need to do, and then I can help you get to that point.